So in this lesson, I'm going to review the three major subatomic particles: protons, neutrons, and electrons. Now this will probably be review for you, but that's fine. We're going to just go through, and then we're going to look at how we can actually predict the number of protons, neutrons, and electrons using the periodic table. Okay? So if you look at this atom on the left-hand side, notice the nucleus, which is densely packed, as we saw Rutherford discovered, and the nucleus is densely packed with protons and neutrons. Okay? Well, protons are the subatomic particle that have a positive charge. Okay? While neutrons have no charge. Now, the important thing to note about protons and neutrons is that both of these subatomic particles, they contribute to the mass of the atom. So when we're talking about the mass of an atom, that mass is a result of the number of protons and neutrons. Okay? While you have this densely packed nucleus that consists of protons and neutrons, you also have electrons outside of the nucleus. Now, remember, an atom has a densely packed nucleus that's positively charged since it consists of just protons and neutrons, and otherwise it's mostly empty space. And that was the discovery of Rutherford, that it's actually mostly empty space, not that the atom is overall positively charged like Thomson thought. Well, what takes up some of this empty space? Electrons. So electrons are actually going to be moving outside of the nucleus in this empty space. Now, what you see here, this concept of electrons orbiting around the nucleus, that is Bohr's model, where he thought electrons had specific energies and they rotated or orbited around the nucleus at these specific energy levels. While electrons do have specific energies, they do not actually orbit around the nucleus. And we're going to be looking at that in detail, but that gets into Heisenberg's principle, which tells us we can't know the position and the speed of an electron at the same time. And instead, what we're going to be talking about is regions where we're most likely going to find electrons. But since that's a little bit messy, and that gets into the quantum model, what we're going to do right now is we're just going to keep this idyllic view of electrons rotating around the nucleus. So what do we need to know about electrons? Well, we know that electrons are negatively charged. Okay? And while protons and neutrons contribute to the mass of an atom, electrons don't. That doesn't mean that electrons don't have a mass. They do. It's just so small, we consider it to be insignificant. So for example, if protons and neutrons, if their mass were represented by an elephant, the mass of electrons would be flies on that elephant. So adding extra electrons to an atom does not change the mass enough that we would actually be able to measure it. So when we're talking about mass, what contributes to the mass of an atom, it's the protons and the neutrons that are located in the nucleus. Now we can actually find the total mass of an atom by simply adding the number of protons and the number of neutrons. And that is your mass number. So your mass number is the mass of a specific atom. And the way that you find your mass number is by taking the number of protons and adding to that the number of neutrons. Now notice the way that I wrote this. I wrote P plus and N neutral. It's P plus because protons have a positive charge. Neutrons are N0. So of course, electrons are going to be E minus. So that's just a shorthand. All right, so you've got your nucleus, protons and neutrons contribute to the mass of the atom. Protons have a positive charge, neutrons are neutrally charged. Electrons, which are, we'll say for right now, orbiting around the nucleus, they have a negative charge, but they do not contribute to the mass of the atom. The mass number, or the mass of a specific atom, is simply the number of protons plus the number of neutrons. So the periodic table can actually help us to determine the number of subatomic particles that an element has. So if you look here, this, for example, for helium, the 2 up top that you would see on the periodic table, that is the atomic number. And the reason why that value is so important is that it actually tells us the number of protons that an atom has. Now, the number of protons defines what atom you have. As soon as you change the number of protons, then you're going to have a different atom. So for example, if instead of having 2 protons, I had 1 proton, I would have hydrogen. While if I had 3 protons, I would have lithium. So this 2 here, this atomic number, defines what element you have. You can change the number of neutrons that an atom has, and we'll talk about that in the next lesson. That will create an isotope. If you change the number of electrons an atom has, that will give you an ion. But if you change the number of protons, you will no longer have the original atom. Okay? The next number that you'll see is 4.003. Now that represents the average atomic mass of helium. Now what this number is exactly what it sounds like. It is an average. So it is an average of all of the different mass numbers that exist for helium. Okay, what exactly does that mean? Well, remember, mass number is the number of protons and neutrons. And remember, I told you that if you change the number of neutrons, you will get what is called an isotope. Okay, so let's say, for example, for helium, you've got a helium atom that has 2 protons, because it has to have 2 protons, and a helium atom that has 2 neutrons. Well, if it has 2 protons and 2 neutrons, remember the mass number is simply protons plus neutrons, so you would have a total mass number of 4. Well, what if you have a different isotope of helium? Remember, it has to have 2 protons to be helium, but instead of having 2 neutrons, it has 3 neutrons. Well, its new mass number is going to be 5. So what happens is because helium can have different isotopes, it can have different numbers of neutrons, it's going to have at least a couple different isotopes that have different mass numbers, right? Because this one has a mass number of 4 and this one has a mass number of 5. To determine the average atomic mass, we'll learn this in another section, but what you actually do is you will average the abundance of these different isotopes in order to determine the average mass. So it's the average of the different mass numbers. So clearly, looking at this average atomic mass here, 4.003, that tells me that the most abundant isotope of helium is going to be helium that has a mass number of 4, because 4.003 is closest to 4. Your average atomic mass simply is an average of all the different isotopes that exist on the Earth. So it therefore can't be used to determine the number of neutrons that one specific atom will have, because they can have different numbers of neutrons, as I just showed you with isotopes. So we'll have to use the mass number, not the average atomic mass, to determine the number of neutrons that an atom has. So before I get into an example, there's one last concept that I need to go over. So I just noted that if you change the number of neutrons, you'll have an isotope. Well, if you change the number of electrons, you will have what's called an ion. Okay? So sodium has 11 protons. So that's 11 positive charges. Well, in order for this atom to have no charge, if I have 11 positive charges, that means I'm going to need 11 negative charges to cancel out the 11 positive charges. Well, let's see if I do have that. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So because I have 11 electrons, sodium is an atom, meaning it has no charge, because 11 positives cancel out 11 negatives. An ion occurs when you lose or gain electrons. Okay, so let's look at sodium here and understand why this has a positive charge. So sodium, remember, still has 11 protons. If you don't have 11 protons, you don't have sodium. Let's see how many electrons it has now. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It has 10 electrons. So by losing an electron, this atom now became an ion. Notice I have 11 positive charges, 10 negative charges. Therefore, because I have one extra proton, it's going to have a positive charge. So quickly to review, subatomic particles. The proton defines your atom. If you change the number of protons, you're going to have a different atom. Neutrons, if you change the number of neutrons, right? For this example, which I showed you with helium, right? If you change the number of neutrons, you'll get what's called an isotope. You still have helium, but it will simply have different mass numbers. And multiple isotopes of an element can exist, and the way that we show the relative abundance of those different isotopes is with the average atomic mass that you see on the periodic table. And lastly, if you change the number of electrons, you will get what's called an ion. So an ion can be positively or negatively charged. If you lose electrons, it'll become positively charged. If you gain electrons, it'll become negatively charged because electrons are negatively charged. So let's see how we actually apply this concept of protons, neutrons, electrons, and mass number in order. So let's see how we actually apply this concept of protons, neutrons, electrons, and mass number. So if I gave you a symbol that looks like the one from example 1, let's talk about what each of these values represents. This number up top is your mass number. Remember, that is your protons plus your neutrons. Okay? The number on bottom is your atomic number, which remember is simply your number of protons. So if we were to fill in this table to identify your subatomic particles, your number of protons here is going to be 7. Let's talk about electrons really quickly. Notice I have 7 protons, and my charge for nitrogen is 3-. So that 3- charge tells me I have 3 more electrons than I have protons. Well, if I have 3 more electrons than protons, that means I would have to have a total of 10 electrons. 3 more electrons than protons gives me a 3- charge. Okay? The number on top, 14, is your mass number. Okay? And so remember, your mass number is simply equal to your protons plus your neutrons. Well, if my mass number is 14, and I have 7 protons, how many neutrons do I have? 7. Okay. Let's look at another example. So here it wants me to actually write the symbol. So I've got 20 protons, so I'm going to put a 20 here. Okay. I have 20 neutrons, so if I have 20 protons and 20 neutrons, then I know my mass number, which is protons plus neutrons, will be 40. So I'm going to put this 40 up top. Now I've got to figure out what element this is. Well, if I have 20 protons, if you look at your periodic table, the atom that has an atomic number of 20 is calcium. Okay? And the last part is I need to figure out the charge of this atom. So if I have 20 protons and 18 electrons, what that tells me is I have 2 extra protons. If I have 2 extra protons, then that means I have a 2+ charge because protons have a positive charge. Let's look at the last example. Here I tell you have 11 protons, so that's going to be my atomic number on bottom. Okay? And I have a mass number of 23. So I'm going to put that up top. Okay? I'm going to figure out what element this is first. So if I look at my periodic table, what has an atomic number of 11? Sodium. Okay? And let's figure out the charge. If I have 11 protons and I have 10 electrons, that means I have 1 more proton than electron. So since I have 1 more proton, it's going to have a 1+ charge. Now, when we're working with charges, you can simply put a plus instead of 1+. If you ever just see a plus, that implies that the charge is 1. So it has a plus charge because it has 1 more proton. Now to determine the neutrons, remember mass number, which is 23 for this problem, equals the number of protons, which is 11, plus the number of neutrons. So if I subtract 23 minus 11, I get my neutrons, which is 12.